Good morning to all. Please receive a warm welcome on behalf of the Inter-American Institute for Cooperation in Agriculture. In this occasion, I will be moderating Rocio Campuzano together with Dr. Erika Calderon of the Program of Health and Food Safety. She is in Costa Rica, I'm in Mexico. Thank you very much. Today, we have exceptional guests. We thank you all for that, for being here in this seminar. And we're going to be having a slight change today in the agenda. We're going to begin with Dr. Carmina Gallardo because she has to travel today. So she has requested to begin. Then we will continue with Dr. Marisa Arias. And afterwards with Dr. Eric Breton and his team. And at last, Dr. Robin Joseph. I'm going to summarize the CV of Dr. Carmina Gallardo, which is, as you know, very broad and extensive. I'm going to try to summarize it. Dr. Maria del Carmen Gallardo Fortaura, she is a scientist of public research organizations in the Superior Research Scientific Research Council of the Center of Research in Animal Health, National Institute of Research and Agrarian and Food Technology, which is known as CISA-INEA in Spain. She has a PhD in sciences with a specialty in biochemistry and molecular biology from the Autonomous University of Madrid, Spain. She also has a degree in pharmacy with a biosanitary major from the Complutense University of Madrid, Spain. Part of her general quality indicator, she's got 20 years of research, the last up to 2017, and five-year terms. The last one ended in December 31st, 2018. Her career has been dedicated to African swine fever, which is one of the diseases that currently represent one of the greatest challenges for animal health. She began her career in 1999 when she became part of CISA for her PhD dissertation, which was entitled Development of New Methodologies for Serological and Molecular Diagnosis of African Swine Fever. After 2004 up to 2009, she did a fellowship in the International Research their Institute in Nairobi, Kenya, with diagnosis studies and molecular epidemiology for African swine fever. And through an important work of technological transfer, she was able to implement surveillance plans in a more effective manner in some regions of Africa. And then we have a whole list of very relevant contributions, which are plenty. So in the interest of time, we're going to leave it here. But we all recognize the great work of Dr. Carmina Gallardo. Without further ado, Dr. Gallardo, you can manage your own presentation. Should you have any issue, just let us know and we'll assist you. Go ahead. Let's leave the questions for after the presentation. And if there is no time, because you need to travel, we will send you the questions afterwards. We would ask the participants to please send your email in case Dr. Gallardo cannot respond readily, so that she can do so afterwards. Just a clarification. Remember that the questions are done through the chat. So please, we have two chats, a direct chat and one for Q&A. So thank you very much. Thank you, Rocio, for your introduction. And thank you very much for the invitation to this webinar on African swine fever. As Rocio has told you, my whole career has been dedicated to African swine fever, working in the Research Center for Animal Health, which is the reference lab of FAO and the European Union for African swine fever. My career has been dedicated to diagnosis of African swine fever, and this conference is based on this introduction to the main diagnosis techniques for the detection of African swine fever, and why is diagnosis so important for the control of this disease. The first would be to ask ourselves, even though I guess many of you already know, what is African swine fever? Well, this is a hemorrhagic disease that affects the swine species. It's classified by WOH as a disease of compulsory declaration. This means that it is a communicable disease that is going to have a great power of spreading and serious impact and serious socioeconomic and health consequences, which might affect international trade. The appearance of the first time of this disease must be communicated to WOAH within 24 hours. Swines are the only species that are to be infected by the African swine fever virus, but in some regions and in specific epidemiological situations, it's important to have the presence of biological vectors such as soft ticks of the Ornithodorus genus, which are present in some regions. But we have important epidemiological differences, considering where the African swine fever is present. Of course, the most important thing is in Africa, or when we have one of the most complex epidemiological situations. It was discovered in 1921, and since then it has remained endemic. It was discovered in Kenya with the import of European ticks during the colony. This is a very complex epidemiological situation, which is the presence of the jungle cycle, which prevents African hogs, warthogs, and the bush pig. But the characteristic is that these African swine are totally resistant to the disease. It's totally contrary to what happens outside of Africa. This case, for example, we have the domestic pig. We have also ticks in some regions. But the most important thing here is that the European hog, contrary to the African hog, is totally susceptible to infection. Clinical symptoms are going to be just the same as those of domestic pigs. In this slide, we have the situation of African swine fever up to 2007 to place you into context. Up to 2007, African swine fever continued to be endemic in sub-Saharan Africa in more than 20 countries in sub-Saharan Africa. It had been eradicated in the European continent in 1957, coming from east of Africa. It was also eradicated in the American continent, where there were some sporadic incursions in 1978, but it was endemic up to 2007 in Africa and just in Europe in Sardinia, which is an island in Italy, where it had been endemic since 1978. But the situation totally changed in 2007, because in 2007 there was a great transcontinental leap coming from the east of Africa to Europe. In April 2007, foci were declared of a hemorrhagic disease close to the port of Poti in Georgia. We must consider that after this only point, and due to the delay in the recognition of the disease, which at the beginning was only based on clinical symptoms and diagnosis was not used. In fact, the first outbreaks were declared 2 months later. This entailed a quick spreading in the regions of the Caucasus, reaching Armenia, Azerbaijan, the Russian Federation, Ukraine, and Belarus, affecting domestic pigs and hogs. And it entered the European Union. The first outbreaks were declared there. through infected hogs at the borders. And since then, for you to realize what this single entry meant coming from the east of Africa, since 2014 to 2024, 17 countries in Europe were affected, being the hog, as you can see in this slide, the main affected species. You can see that the African swine fever is the pandemic of animal health. Since 2007 up to 2024, 77 countries have been affected in 5 continents. And this after one only focus in Georgia. As you can see, another transcontinental leap, another epidemiological change was the declaration of the outbreaks of African swine fever in China in 2018, affecting the largest pig producer worldwide. In 2021, it took another large transcontinental leap, and after 40 years, outbreaks were declared in the American continent, specifically the Dominican Republic and Haiti. It is clear that this is the pandemic of animal health. The question is, how can we fight this situation? To fight African swine fever, it's important to know the virus as well as the disease, know its mechanisms of transmission, its genetic characteristics, biological characteristics, and clinical evolution in affected areas. This will facilitate early detection based in the application of effective surveillance programs. We must always remember that preventing is better than curing. What do we know about the African swine fever virus? Well, this is the only virus that's member of its family, and it's a very complex virus if we compare it with other swine viruses like classical swine fever and others. It has a very high number of genes, almost 200, of which many of them we do not know what their function is. One characteristic that has made it hard or impossible to have a vaccine, even though we've known this for more than a century, it is that there are no neutralizing antibodies in an effective manner. It does not produce them. The infection persists for several months, the live virus, and target cells are macrophages, which is a cell that is essential for the immunity defense of the host. We have to consider also that this virus is very resistant in the environment. It will remain viable during long periods of time. We have some examples here. For example, in blood at 4 degrees, it can remain viable, effective up to 18 months. In contaminated stables, the virus will remain infectious for at least 1 month. And here I have marked in red that in frozen meat, we can have the virus perfectly alive and infectious up to 30 months or more. That is why it's so important to have the biosafety measures to control African swine fever. From a genetic perspective, we know that there are 24 genotypes, but this characteristic is based on the analysis of a small protein, P72, which is the majority protein in the capsid, and this analysis is a concept that is only molecular. It is not associated in any case to virulence or technical symptomatology. I have to point out that genotype 2 is the cause of all the outbreaks that have occurred in Europe, Asia, and America, even though there are different variations within genotype 2. African swine fever, regardless of the genotype that's circulating, is always African swine fever. How it is expressed shall depend on several factors, as could be the virus and the dose, the route, the host, the scenario we have, if we have any concomitant diseases. That is why it's very important to recognize the disease at the field, to know what are the clinical forms of African swine fever and how it will behave. Let's see what is African swine fever and how it expresses itself. As I said at the beginning, African swine fever is a hemorrhagic disease, and therefore, in its more acute forms, it's hard to differentiate from a clinical perspective from other hemorrhagic diseases. A clear example would be with a classic swine fever. As I said, with the introduction that occurred in Georgia in 2007, a cause of the great expansion that occurred was the delay in the diagnosis of the disease because the lab diagnosis was not used. It was merely diagnosed as another hemorrhagic disease without stating that this was ASF. The lab diagnosis is essential for early detection of the disease when there is a minimum suspicion of hemorrhagic disease. In this slide, we see the different clinical forms of the African swine fever. We are going to have four main clinical expressions. One, it would be highly virulent, which are going to cause cases that are hyperacute or acute. In these cases, mortality is between 90 and 100%. This only happens when the virus enters in a free population or in a country where there is no ASF. There would be high mortality. In some cases, in hyperacute disease cases, we are not going to see any clinical symptomatology, and animals are going to die suddenly. As the disease appears as endemic, if it's not eradicated in the first moments, we're going to have evolution through time, and we're going to have different types or different viruses circulating. We're going to have the highly virulent viruses, but this is also going to pass on to moderately virulent viruses. For these viruses, we could have four types of the disease: the acute, subacute, chronic, and subclinical. In this case, incubation time is higher. Death occurs in 7 to 22 days. And here we can have between 30 to 70% survival. And in those areas where it is endemic, the viruses are going to evolve. They're going to have a low virulence or attenuated, which can be the cause of chronic or subclinical forms. We're going to have an increase of survivors to the infection, and it's very important to identify these survivors and possible carriers of this virus, because these low virulence strains are going to induce a type of subclinical and chronic infections that are very hard to recognize at the field. This has been one of the large issues that we have had, and we thought that for African swine fever, if we do not eradicate it, viruses evolve and they can produce different clinical forms of that disease, many of which we're not going to recognize at the field. That is why it is essential to base ourselves for early detection in three fundamental pillars. Of course, it's important to note that we have these clinical forms and we have to recognize the disease at the field, have a good lab diagnosis, and all this has to be combined with epidemiological data. Based on these three pillars, we can apply effective surveillance programs. These effective surveillance programs for early detection, and considering the characteristics of ASF, this is going to be mostly based on a passive surveillance, which will be with the investigation of the clinical signs and mortality, which will have a fundamental role in early detection. For example, in Europe, where wild boars are one of the main affected with African swine fever, it is very important to detect it on cadavers and also eliminate this. Also, considering this evolution to more attenuated forms is going to be very important to have active surveillance, because this will allow us detecting these survivors to the disease. Surveillance, to be successful, must have the support of an adequate laboratory for a quick diagnosis. As has been said, the lab diagnosis is essential in the control of African swine fever. Basis for a good diagnosis. To have a good diagnosis, we have to have these 4 points. Appropriate samples. We need to know what are the samples that we need to work with. Use tests that are perfectly well validated internationally. This is very important, and these have to be applied to the appropriate samples. Know what is the workflow that needs to be followed, considering we're in a free zone, if we are fighting against a primary focus, or if we are in an endemic zone. And very importantly, the interpretation of results. And I insist, after an outbreak of African swine fever, if it's not eradicated in its first phases, it would then, through time, months or years, we're going to have viruses of different virulence that make it difficult to recognize at the field and make diagnosis the only way of detecting African swine fever. Let's move on to the first point. What are appropriate samples for a good diagnosis? Of course, serum. Serum is essential for active surveillance studies. We have to consider that when we receive hemolyzed samples, they can negatively affect serological tests, ELISA tests. Of course, blood and the organs. Organs are mainly the target organs are the spleen, the lungs, kidneys, tonsils, the heart, and lymph nodes. And it's also very important in the case of wild findings, the bone marrow. To have a reliable diagnosis, we have to combine the right samples with adequate diagnosis methods, depending on the epidemiological situation. For an early detection, of course, the technique to be chosen is that of PCR. PCR tests, which can be applied in all types of samples, in organs, blood, or serum, all types of samples. Any suspicion we have of African swine fever, that would be the technique to be used. If we have a primary outbreak, it is recognized, if at all possible, to have viral isolation and identification by means hemoadsorption, because this is a specific characteristic of African swine fever. This is done in all types of samples in organs, anticoagulated blood, and serum. It is not allowed to determine phenotypic characteristics of the virus that's circulating. And why? This is important because we can also identify isolates that are not hemoadsorbent. In this picture, we can see what hemoadsorption is about. It consists that after the target cells have been infected, we add erythrocytes to these macrophages, and we have all these spots, which are very typical and characteristic of African swine fever. But as I told you, if this continues to be endemic, there is going to be an evolution to another type of virus. These viruses that can be non-hemoadsorbent are normally attenuated viruses, and they're very important to identify in the field. Another technique for early detection and for the detection of African swine fever virus would be the detection of the antigen by means of direct immunofluorescence using organs as target samples, or ELISAs for the detection of the antigen of the African swine fever virus. In this case, we only have a commercial antigen ELISA. We can use organs or plasma from anticoagulated blood. And in these tests for antigen detection, we must always remember that these techniques have low sensitivity. Why? Because antibodies in front of African swine fever occur early in the infection, between 7 and 8 days. That is, when antibodies are going to be present, for example, in anticoagulated blood plasma or in organs, we're going to have false negative samples by means of antigen detection techniques. This is why they are in parallel with antibody detection tests. Of course, another type of very important techniques for detection of survivors and possible carriers of African swine fever virus are those techniques that are based on the detection of antibodies. Of course, the technique that has been prescribed for epidemiological surveillance studies using serum and plasma is the ELISA technique. For a sieving, there is a broad variety of commercial ELISAs that have been validated for analyzing these samples. This analysis of alternative samples like tissue exudates, oral fluids, and other samples or ELISA tests require field validation studies. These ELISAs are validated for the analysis of serum and plasma. A diagnosis is going to be feasible if it is applied that the type of the sample is appropriate. Another technique for antibody detection is the immunoblotting technique that's used in serum, indirect immunoperoxidase, and indirect immunofluorescence. These two last techniques are very important techniques because they help us perform epidemiological studies and determine the moment of infection, because these techniques are highly sensitive, but also they are very versatile. We're going to analyze different types of samples, all types of samples. That is, if we receive the tissue of a dead wild boar, we're going to be able to analyze them through these techniques and to see if the antibodies are present. And combining antigens and antibodies or virus and antibodies, we're going to be able to determine what is the state of the infection for the specific animal. We have alternative samples that are being used, and amongst them, I have to point out that oropharyngeal tests or blood tests have proven to be the more promising alternative samples. We need to bear in mind that sensitive results will depend on the virulence of the strain. We must always remember that when we use a sample and a third diagnosis, they have to be validated. I also wanted to show you this slide because recently we have described a field test that allows us giving a quick response to outbreaks and the control of the spreading of African swine fever in endemic situations. We have the lateral flow devices and also molecular tests, which have the portable PCRs lamps. These latter ones, even though they have a high sensitivity and specificity, they will require more specialization and are more expensive. I wanted to show you here in this slide this field test, which is the combination antigen antibody, which allows us simultaneously detect an virus and antibodies. This will allow us to detect it in 20 minutes.
Porcina africana, muy buenas técnicas de diagnóstico que están ampliamente validadas.
Many different diagnoses, and we can see this being effective, but according to surveillance programs, it will depend on this application, which if we are in a free country, endemic country, or we're fighting against this outbreak, because we will be able to look at this. What would be the workflow if we are suspicious of an outbreak of ASF, of a hemorrhagic disease? Of course, we have the technique of choice. There are many PCR methods, both commercial and described by OMSA, that are highly sensitive and that capable of detecting all the genotypes that are circulating. We can also analyze different samples, blood, tissue, and among others. If we have a positive or fluids and serum, if it's positive, it means that we may have a positive PPA. ASF, but if it's a primary outbreak, we need confirmation by viral isolation, and if it's not possible, by genotyping. All of this in together if we're faced with hemorrhagic disease with the clinical symptoms to confirm the outbreak. But what happens if it's negative for the virus? We can detect the presence of ASF. Well, what would be the next step? It is very important to have the detection of antibodies, particularly if we are in endemic areas or in areas of risk that are next to areas with ASF. So if we have a negative outcome and the PCR is negative, of course, we can discard that we have ASF. But If we have a positive outcome, it means that we have animals that have survived to the infection and may act as a potential carriers of ASF. So the diagnostic information will not tell us only if it's positive or negative to ASF. It will also give us information that is epidemiological information of the clinical evolution of the affected areas, or to the determination of the infection time. For example, in the case where we are, then a primary number, and if maybe we can determine the origin or when the virus of AFS has been introduced in a certain farm or region. And how are we going to know this? By interpreting the diagnostic results. The interpretation of the diagnostic results is very important, and it will give us lots of information from the epidemiological standpoint. In this slide, we can see how at the beginning of the infection, as I have mentioned, the normal thing is to have acute forms of the disease. Here we have high mortality, and here what we're going to have in the early stages of the infection is between 0 and 7 or 12 days is a high level of virus. It's going to be very positive by the PCR technique, and we are going to have either negative antibodies or it's going to be in the limit of detection. So as the disease evolves, what we're going to have is the emergence or virulent and low virulence viruses. Here, the curve moves to the right. The viremia will disappear after a month, or we're going to have intermittent viremia, but it's going to be characterized because after the second week, we will have a high titer of antibodies. In late stages of the infection, the infected animals or that have survived the infection will be easily detectable by serology if there's no viremia and in the absence of symptoms, clinical symptoms. And this slide, I would like to highlight that attenuated virus can induce chronic to subclinical infections characterized by high antibody titers and negative or weak PCR, even at the onset of the infection after 7 or 8, 10 days. And it can be positive, negative, or very weak again. So the serological diagnosis is essential to detect this type of subclinical infections or with unspecified symptomatology for ASF that produce these attenuated viruses. These attenuated viruses, let me remind you, are usually present in the endemic areas of the disease. So the interpretation of the outcomes or the results will help us by combining the virological diagnostic techniques, that is PCR with serological ELISA and IPT, or indirect immunofluorescence because of its high versatility for the analysis of all type of samples. It will help us to determine if we are facing an early stage. If in this case we have a weak PCS and negative antibodies and IPT negative, and if we have a PCR weak, we are facing an early infection. The animal has been recently infected and has not yet seroconverted, and clinical signs may not be evident. As the disease advances and we have an acute moment of the disease with clinical symptomatology, we have very positive PCRs. We will have between 7 and 8, 10 days. The animal has been recently infected. It develops clinical signs and is initiating seroconversion. In this case, we will detect it by indirect immunofluorescence and immunofluorescence. So with PCR, it will be detected anyways. The infection is a current infection. The animal is still viremic with clinical signs and has already seroconverted. So we can detect this through all the different techniques, through PCR, ELISA, IPT, or immunofluorescence. And then, as animals survive, we will have a PCR that may be weak or intermittent or negative. But in this case, it is going to be very positive for antibodies, and we will detect it very easily using ELISAs and also the IPT or immunofluorescence, indirect immunofluorescence. So in this case, we will have a past infection of over a month. The animal has recovered from an acute or subacute infection and showed or it's not showing no clinical signs anymore. And also, we can have a reinfection, that is, a surviving animal suffering a new infection. In this case, we would have a weak PCR or an animal infected with an attenuated strain. And let's remember that in this case, this can be PCR negative to be at the beginning of the infection, or it can be antibody positive with a very high titrate of antibodies. The surviving animals that are affected by this type of strains are negative of PCR, but high antibodies. So these animals that are seropositive and negative seropositive in blood have the infection, have the capacity to, do they have a capacity or do they have a role in the epidemiology of the disease? Do these animals have the capacity to infect a free population or do they play an important role in the epidemiology of disease? Well, animals that survive acute and subacute infections excrete the ASF virus through oral excretions for up to 22 to 30 days and through blood for up to approximately 44 to 60 days. That is 2 months after the infection. They would be virus carriers during this period. And so potentially they can be carriers and transmitters of the virus. And so they also have viruses in tissues. There's presence of viruses in the tissues, and the virus is going to clear more or less rapidly from the target organs, such as the bone marrow, the spleen, or the kidney, approximately after a month. It is very hard to see that is positive in this type of tissues. But according to the studies developed, it has been seen that it can persist for more than 2 months and even up to 4 months at primary replication sites such as tonsils and lymph nodes, or at secondary replication sites such as intra-articular tissues. Therefore, these tissues should also be considered in surveillance programs to detect carriers. Therefore, ASF control is highly dependent on laboratory diagnosis. Let's remember that there's no world vaccine for ASF, so if we detect antibodies, it means that we are detecting the infection. The laboratory diagnosis will allow us to do an early detection, and it also allows us to obtain information that is very important on infection dynamics, and this will support the prevention and control programs of the disease. We need to understand that for all of these, the epidemiology and the dynamics of the disease in the affected areas. In combining with a good diagnosis or proper diagnosis, we can control the disease in affected areas by ASF. And it is very important to highlight that we need an active collaboration and exchange of information between the veterinary services and the laboratory. Among the regional laboratory services, among the different district veterinary service or local vets, the regional laboratories, national laboratories, and international laboratories. The coordination among all of us and the support among all of us is key to control ASF. Thank you very much for your attention. And if you have any questions, please go ahead. Well, thank you very much. We have a couple of questions, and maybe we can answer them before you leave us, Doctor. Let me see. The first question is by Alejandro Perez. What epidemiological situation should there be in a region that is different countries to recommend a passive surveillance? For passive surveillance, at least in Europe, it is recommended always for the early detection of the disease. That's the type of surveillance that is recommended. Passive surveillance is recommended based on the detection of clinical signs in the case of farms and in the case that the population of wild animals to look for dead animals in the field. That is key for early detection of the disease, passive surveillance. Thank you, Doctor. Next question is by Lynette Peters, 2-in-1. What would be the epidemiological surveillance like in countries that have not had the disease? And are you working on the development of a vaccine? Thank you. Well, with regards to surveillance programs, that will depend on each country, but what I have mentioned, is to look for passive surveillance, to look for clinical signs and dead animals in the field. And in the case of vaccines, yes, people are working on development of vaccines. In fact, there are some commercial ones that have been applied in Vietnam. And according to Marisa, maybe Marisa can mention that, we are working on the development of vaccines based on attenuated living viruses that have to do with virulence. They are well advanced with the ACNIVA project in Europe, and others are also working intensively in the development of vaccines against ASF. What we need to have into consideration is that the vaccine, of course, will be able to help to control the ASF, but it's not the solution for the control of ASF as a whole completely. It has to be combined with a right surveillance program and good diagnostic systems as well. So thank you, doctor. And we're going to take the other questions and send them to you because you need to take your flight. And there's one in the chat. I don't know if we have time for one more. Yes, 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 yes. Okay, of course. It says, how can we distinguish the meat that is being traded from other countries and coming into Mexico that may be coming from sick animals? Well, through the PCR technique, you can detect meat that is contaminated. There are countries that are doing the PCR technique in meat that is coming from infected by ASF infected countries to see if there is an ASF infection in the meat. Even though the PCR is positive, the meat needs to be destroyed. It is also important to take into consideration that depending on the processing of the meat, even though it is PCR positive, it doesn't need to be necessarily infectious. Okay, thank you. So Carlos Yamnes from Sinacica, Mexico, is asking, how efficient are the detection techniques for non-conventional samples or alternative samples? In non-conventional samples, such as oral and oronasal swabs, and the detection in this case, it is always recommended to see the low virulence to combine PCR and an antibody detection technique because they will be positive only in the antibody and not in the PCR. Well, doctor, there are 3 more questions in the question chat. I don't know if you have time. I think so. I think so. Yes, I have time for one more. So from Carla George, it says, are there any data on the safety of or security of the samples that use saliva to look for the PPA antigen? Well, there are tests that say that it can be definitely detected through PCR in the case of acute outbreaks. Of course, it's going to be detected through PCR tests. In the case of antibody detection that is less sensitive than conventional tests, yes, of course. And I don't know if it's not only infectious, but it's not infectious in the sense that if they are infectious, yes, they are infectious, this type of samples. But in the sense that they can be detected, yes, they can be detected because especially we're in acute or subacute cases of ASF. Yes, they were talking about how much we can trust them. Yes, if they be detected, if it is an acute or subacute case of ASF. Thank you very much, doctor. No, you're welcome. Thank you. And thank you very much for all the interesting information you shared with us. It's very updated and very useful for all countries, particularly those countries who are just reinforcing their measures in their labs and surveillance programs. So thank you very much for that information. I think you have also given us very good tips. And this is not only basic, but this is a tool, another tool, together with surveillance in the field and the tests that can be carried out in the field. So thank you very much, Dr. Carmina. No, thank you, and have a safe trip. Oh, yes, thank you, thank you. So if anything, Marisa can also answer some of the questions, or I can answer them by mail too. Okay, perfect. Thank you very much, doctor. Thank you. And before we move on to the next presentation, I would like to tell all of our participants, we have Dr. Diego Montenegro with us. He is a representative from ICA in Mexico. Doctor, I don't know if you would like to give us a few words. Or you would like to say a few words? No, just very briefly. Just I would like to greet everyone. This type of events definitely give us much uh, motivation and such a very important and relevant topic in the sense of surveillance, diagnosis, and such an important topic for the Americas and for the entire world. So thank you. Let's move forward. And thank you, Erika. Thank you, Rosito, Marisa, and all the amazing presenters that we have in this event. Thank you. Well, thank you very much, Doctor, for your greetings and your message. Now we are going to listen to Dr. Marisa Arias. She also has a very extensive CV, but she sent us a summary, so we're going to read it very quickly. Dr. Marisa Arias is a animal health research professor at the Animal Health Research Center CISA of INEA in Spain. She's a researcher and she was director in different periods. She is the director of the AFO European Union Reference Laboratory for African Swine Fever and the technical director of the Reference Center of FAO for African Swine Fever. Along her career, she has participated in over 75 projects, research and development projects at the national level and internationally, and in different scientific and technical cooperation programs. Dr. Marisa has contributed with over 165 scientific and scientific technical publications. Among other things, she has participated as a lecturer in conferences, symposia, and international workshops in at least 50 as a keynote speaker. She has received 3 national scientific awards for her research and merit for her research activities, and as director of CISA, the Cross to the Merit provided by the Madrid police and faced with the COVID-19 from March to May in 2020. She has participated in 23 national committees and national international committees on infectious diseases in animals and biosecurity. She also participates frequently as coordinator or director in over 57 international courses on animal health organized in Europe, Central America, and South America, with a special relevance of ASF in the past few years, and also on the prevention, diagnosis, and control of viral diseases, emerging and transparent animal diseases. Well, doctor, your CV says it all. Well, thank you very much. Thank you very much for being with us. Oh, thank you very much, Rocio. Let me share my screen first. Let me see. Can you see it? Yes, we can see it. Okay, perfect. I might have some technical issue here with my computer, but thank you very much, Africa, Rocio, Katia, Erika, for your invitation and this invitation to that you extended to us. We definitely very excited to participate in anything we can. We're very intense people and we love to participate in any type of project. And I think this is the time to help the Americas to prepare to the arrival of ASF. So the title of my presentation is The Diagnostic Laboratory in Epidemiological Surveillance and Emergency Care Systems, Preparing a Laboratory Contingency Plan. So we specialize in the preparing a laboratory contingency plan, and then I'm going to finish with some messages looking at the 77 countries and territories that have been affected while in 2007 we had only 20 or a little bit over 20 in Africa. Look how the disease has spread it in such little time. This virus is a very smart virus. That's the first thing we need to know. And everybody has underestimated at the beginning this disease. So it is already in the Americas, regretfully. It was in the 70s, as you might remember. And what Dr. Gallardo has said, I would like to highlight something. First, that the virus that crossed from Europe to the Americas in the 70s, which was eradicated in many of the places by sacrificing all the boar population or the pig population, was it was virulent. There was no non-virulent. That's based on the studies that were carried out later on in the Americas and the US. Is it going to arrive to other countries in the Americas? Yes, certainly. When? Well, we need to see. We'll need to wait and see. So the first I would like to say is that even though some of this has been mentioned by Dr. Gallardo, this disease is a very complex one, and it has always been underestimated. It has different players. The domestic pig, the African swines, then the European swine, the African swine, and they all have different susceptibilities. We know that in Africa there are certain domestic quote unquote pigs that are much more resistant than the white European pig, and there are other different transmission cycles. And as Dr. Gallardo was saying, a biological vector, the soft ticks, and thank God they are not widely spreaded. The one for the genus Ornithodorus that we have the Erraticus in Europe and the Muvata, which is in Africa. But the epidemiology is going to be very complex, not only because of all of this, but because not all the players that I've mentioned different type of hosts that exist will be present, but also even though they may be present, they might not always play the same role. And you are going to see the disease in one way or another. Based on what Dr. Caminos Gallardo's presentation, many people do not believe about this disease. It is always African swine fever, but how it's going to express itself will depend on many factors of what players are intervening, what is the situation, the epidemiological situation, the ecology of the area. There'll be many different scenarios. Even the disease in Europe, as you might have realized based on the map that I have shown you, the part of the EU has to do with the African swine fever, and it is in the wild areas of the boar. But in the eastern part of Europe, it is in the domestic and also in the wild boar, but there's an important intervention of domestic animals. In Asia, we have little information. It's not being very expressive, but that there it extended very quickly. What I'm going to be talking about is the points to take into consideration when preparing a laboratory contingency plan. But the first point, you have in many countries contingency plans, laboratory contingency plans for the classic swine fevers. And that may be the basis, might serve as the basis, even though they are completely different viruses, they still have something in common and they produce a hemorrhagic symptom that is very similar, although they are very different. And because of this clinical similarity, oftentimes they are confused. I have taught a course in the Americas where I had veterinary experts and experts from veterinary services from many countries. I showed them a video of the disease in classical swine fever and another video without telling them of African swine fever. And out of 23 people, only one identified which one was the African swine fever. The others thought that it was classic swine fever. So please don't take things for granted. And so having a very good knowledge of the disease and the complexity of this disease is key. And knowing the virus, this is a very smart virus that stays and not only stays or remains as the Jeski disease, but that is latent. No, this one is living, is live, and it can infect any time. It is hidden somewhat, but in the end it comes out and there may be lots of virus, but it's hidden. and it's hidden for months in the joints, as mentioned by Dr. Gallardo, and even in the lungs. So having a good knowledge of the disease and the virus, knowing the basis for a good diagnosis, which have been very well summarized by Dr. Gallardo. I know that if you're not used to the diagnosis of PPA or ASF, sorry, might seem complicated, but these are very simple techniques. Some are even in-house, and some of the analysis, the ELISAs can be done in-house in the laboratory, and they may be very cheap. And it is very important for the diagnosis done to be done with procedures that are validated tests. Also, in a contingency plan, what needs to be expressed, and these are the points that we taken into consideration that need to be already within the plan, is we need to talk about the disease, talk about the diagnostic techniques and the resources and that may be available to do a fast and reliable diagnosis, and the minimum requirements to face an emergency situation that all countries should prepare, because you have it closer than you think, and you need to prepare yourself now. Something that was mentioned by Dr. Gallardo, the differential diagnosis is important with other swine hemorrhagic diseases is key, and using the lab is also key to be able to give a reliable diagnosis of ASF. The 4 points that she has highlighted. Appropriate sampling. These are essential points, because otherwise you won't have a good diagnosis. If you don't set a good sample, we need to understand that there needs to be a very good relationship between veterinary services and diagnostic laboratories. Also, to use validated techniques and kits. Let's see, we need to see if we are dealing with a primary or secondary outbreaks, and we need to see what we are going to be using and the interpretation of results. All of this needs to be in a contingency plan. It needs to be written down in a contingency plan. This contingency plan from the laboratory or laboratory's contingency plan needs to be part of the national contingency plan. It has to include, as we have said, information and characteristics of the disease, the dynamics of the disease, and information, laboratory information of your country, and make sure that the laboratory is capable of operating effectively and without delay during a disease outbreak with the necessary quality standards, and to serve this PCR or this laboratory contingency plan needs to be a reference manual for all personnel that will intervene in the laboratory in the event of a contingency. So it has to be very clear. It has to be precise and concrete.
Let's analyze now everything that this must include. This is everything that a good contingency lab plan must include. First of all, it has to describe what is the infrastructure and space that's going to be expanded, what staff is going to be involved, what equipment, reagents, and fungible material inputs, supplies are necessary, the management of the samples and traceability, how is this going to be done, define the different steps and where it is going to be expressed, administrative management and procurement management, databases to be developed, validated methods and normalized working procedures, and the interpretation of results. Because afterwards, when giving a final diagnosis, it's not enough to say this is a positive PSR. That's not a diagnosis. That's the result of a technique. We must know how to make a final diagnosis, and we must define how to reach that final diagnosis. When is the funding going to come out of all the things that I need to buy and what I need to have in stock? And if at all possible, I don't know if in Europe, because it's mandatory in the European Union, we work with ISO 1725 quality system. Why do we need to work with a quality system? Because a positive that appears in an area in a country has to be admitted as positive in another country, and a negative has to be negative elsewhere. If you do not have a quality system, your results are not going to be reliable or trusted. That's why you have to follow quality standards. Let's develop these points. Facilities and necessary equipment. We have to describe in the contingency plan the thermal cycling equipment, centrifuges, lab material, thermal blocks, readers, microscopes, etc. All the equipment that is necessary. Then we need to define and appoint the people who are going to be qualified, who are going to be doing this lab analysis, the diagnosis, and they have to be trained. And also, we need to describe what reagents and diagnosis kits are going to be used, and they have to be validated. If it's not validated, it's no good. We all have the experience with of COVID that countries were working with kits that did not work at the beginning because this was an emergency. But in this case, if there is something good that the ASF has, which is the only good thing it has, is that they are very good commercial diagnosis kits that have been validated and very good techniques and know-hows. That if you do not have much money, you can just do them in your own lab and they're not so expensive. And they are very good and they are highly sensitive and specific. It's easy with good techniques to work on a good diagnosis. We have to buy reference reagents where, well, WOAH labs, FAAO labs. We sell to labs when they require this, not always, but because when we need to go through the Atlantic Ocean, there are many requirements for the procedures for submitting these things, but some things never reach the other side. But for example, SIRA reference panels for internal verification, those things we can supply. And we will keep in contact with whatever you might need. For the management of samples and traceability, is fundamental to identify the sample that you receive, provide a lab identification, but always having the traceability of the sample that you are receiving from veterinary services and the field that's coming, looking at the lab that's a provincial lab or the own reference lab, what's being sent by the vet. And communication among veterinary services in the labs is fundamental because otherwise you're not going to be able to relate epidemiological data with the samples and to be able to do an epidemiological research and to know how long that animal had been infected, what type of virus this is about. Is this a moderately virulent virus that are the most complicated ones? Well, let's see what is the percentage of survival that I can expect. All that information is provided by diagnosis, not lab analysis that everybody confuses. The lab tells me it's positive or negative. No, it's all the epidemiological information that diagnosis techniques provide. That way, you can know everything that Dr. Gallardo spoke about. Validated methods and technical procedures. We have spoken about this. All this has to be well reflected in contingency plans at the lab. What diagnosis tests are you going to be using in case of a suspicion? What's the order in which you're going to be using these? What's the maximum capacity of your lab? If you can just do 10 PCRs, well, 10 PCRs, but say it, express it, or 50 or 100. But we know that with good validated PCR techniques, we can do this in groups of three. If you're analyzing one single farm, you can have 3 samples of 3 different animals together. No problem with that. For the wild part, it's kind of more complicated because you lose sensitivity. But anyway, it can also be done because that way we save some of the cost of the tests. But if there is a clinic, I advise not to pull it, but to analyze what's happening in each animal. Detailed description of normalized procedures of the work. All the work procedures, the SOPs have to be all included in the contingency plan. And a detailed description from the arrival of the sample up to the final diagnosis, including receiving, preparing, controlling, and storing them. the quality control of the reagents, the sample, the steps of traceability, and afterwards the storage. Interpretation of results, final diagnosis. It defines how are you going to do, what are you going to do with a non-conclusive diagnosis? What are you going to do with that? How are you going to do to give the final diagnosis? Everything is going to have to be final. Who are you going to be sending these to? International standards that need to be followed. They have to be reflected in this contingency plan. And we need to always prepare a report, but this report has to have the final diagnosis, which is the virological part. And if serology has been done, we must also take that part in our intercomparison assays that we perform. We always include samples that are negative to virus and positive to antibodies. If vaccines have not been used, a positive antibody is an animal that is in recovery phase, or if it is negative to PCR and positive to antibodies, or if it's a survivor. And as Dr. Gallardo explains, during several weeks, the virus persists, then cadavers of these animals, for example, are very dangerous. One thing that I wanted to clarify is that PCR is positive when we have a moderately virulent virus or virulent that is generally during 20 to 30 days in blood. But then the virus remains in tissue. So that's why we have to go to antibodies to see what's going on in a given animal. If the animal has a virus and is recovering. And in tissue, as the doctor has said, it takes some more weeks or even up to 4 months. There has to be a detailed flow chart of how the information is going to be transmitted among the different areas in the lab departments who's going to be receiving the information, the chief of the section, coordinator, the technicians, how do they communicate this to the direction, etc. Very importantly, this coordination amongst departments. If we have the virology and serology units separate, because we've seen cases in which they have been analyzed by virology. The serological part has been left forgotten, even though it has been analyzed and it has been considered negative when it was positive, and the disease was already there. Administrative and procurement management, hiring, documents, all this has to be clear how it is to be done. Who is going to be responsible for procurement? This is one of the most critical aspects in a lab because generally purchases take time. We need to continue call and why are things not arriving? You have to be always managing purchases. Someone has to be on top of it and analyze the needs of the lab to establish the stock for an appropriate time frame. I believe that you should begin preparing a small stock to the extent possible, but you have to have enough to be able to face a suspicion right away. It has to be ready right away for their contingency plan. Establish a receiving and storage system that is appropriate to the stock that you have, because you do not, well, you have to put things somewhere. Where do I put them? We have 20 reagents. Ones go at 4 degrees, others go to another storage warehouse, different things. I don't know, the pipettes, the different things you need. Implement a stock management program. Add a list of supplies and reagents that are necessary for each technique and know what I'm missing. And to know that at least after every 3 months, you need to restock. Otherwise, you're going to be left without stock, without reagents, and you're going to be without any material for diagnosis. Then you need to have a list within the contingency plan. We need to ensure the contact with companies, and it's always better to have 2 suppliers than 1. What type of administrative contracts are we going to be having? A commercial agreement? What's the real delivery time of the companies? And you can test it right away. Do I need import permits for some reagents? All this needs to be foreseen because otherwise it might take months, 1, 2, or even 3 months. Databases. We need to have a few names, addresses, phone numbers of the technical staff and of the staff that's going to be in charge, the coordinator of this ASF lab. What authorizations and responsibilities for each of these positions they have? We need to describe that. Records of entry and exit of samples, if they're all prepared. It could be one for African swine fever and put them within the contingency plan for sample on samples and reports that afterwards come out with the results. Quality control records for all the equipment, reagents, etc. Analytical results records. That is, you're going to need a report, but I need to have all the results for every test I make. And I have to have a database for that sample with everything that I've done with that sample. And afterwards, the suppliers of the reagents and the lab material, they have to be easy to manage by every manager or all the administration staff or lab staff, because sometimes we do manage these administrative things as well. During a crisis, what would I need? Well, I'm going to need to describe in the contingency plan what additional space I would need. Because if you're currently a free country, you just need a normal lab to do this. Well, you need the two spaces for PCR and a few more things, and a lab for serology. But if I need to work on several samples, I need an additional space. I need to relocate new equipment or an equipment that has been lent to me by another group that is perhaps at the time it's not a priority for them to work on ASF. I need to see where to relocate the staff of the new areas. How am I going to move around the staff, or how's new staff coming to this activity? Do I need to hire new staff or to borrow people who are working in something else? But I need to train these people. How am I going to be assigning the different work teams? Do I need work shifts? We, as an African swine fever lab, we have been in the need of working morning, afternoon, and nighttime during an emergency. Do you have overtime considered? Well, during a very complex situation, sometimes this is not considered, but when this takes time, that needs to be taken into account, and mostly work shifts, because people cannot be working from 8 o'clock in the morning up to 10 at night. You will need at least two shifts. In relation to equipment during a crisis, what additional equipment could I that I need that I can borrow from another lab, or do I need to buy? I need to buy a robot, perhaps. What and how many reagents would be necessary for the first weeks during an outbreak? This is a point that has to be clear, already set in the contingency plan in free countries, because this is something that you would already need to have. Begin buying it. Reagents, diagnosis kits. How many would be necessary in the worst case scenario? Fast procurement of material and diagnosis reagents. I need to look for the most expeditious pathways in Eastern countries, not European Union countries, but in the border. Sometimes for them, it took up to 6 months to get a reagent. I think that that's something that's relatively usual. For us, it could also take weeks to get a reagent. So that's why it's so important to have stocks. That's very important. And also they need to have a long expiration date. And we need to see what to do in case some equipment is broken. I need to replace it. I need to repair it. All these things need to be included in the contingency plan. As Carmina was saying, that I was going to cover this, but not too much communication. We know that diagnosis labs in many countries, I can tell you based on our experience, they do do not tend to be in close contact with veterinary services. This cannot be, because to have an effective control, the reference lab has to be totally in coordination with veterinary services in the country. Then, if my country is a large country, can have different labs that can provide support, because I cannot do all this analysis. So you need to see what's the communication like between the provincial municipal lab with the national reference lab that will communicate with the national country lab. But veterinary services will need to talk to the different regions in the country. This is fundamental. And in any lab that's there at the official level, it has to be coordinated by the national reference lab in that country. And the national reference lab needs to know what regions are being used, what tests are authorized, and mostly knowing that they are prepared with a warranty of quality to do that. They have to have an intercomparison assay or interlab assay to make sure that they are able to provide in a sensitive and replicable manner a good result. Perhaps you just apply a PCR or just serology. Well, that depends on each country. I'm putting back this slide because this is one of the fundamental things. Diagnosis labs provide lots of information on the epidemiological situation and for the final diagnosis. So there are a fundamental pillar for good control of the disease. In my opinion, someone from the national lab that knows the disease and the virus really well, that knows about diagnosis techniques, that knows to work on diagnosis, the final diagnosis, and who can interpret it, has to help veterinary services to work on this interpretation. Something else is that veterinary services decide what to do or not with that information. I recognize that all countries at the end decide that what they believe is more appropriate for the country, and they shall provide total, partial, or as they consider regarding information. But if you want to have good control, you have to have full information. If you just want to know if you're positive or negative, you will not have good control and you're not going to eradicate ever. Spain eradicated. I was in the program for control and eradication of African swine fever, which was in existence in Spain since the 60s until the year in which it was declared free in 1995. I was there in the last 10 years, but we were totally in agreement and in close communication with veterinary services. Otherwise, it would not have been possible. But not only that, our veterinary services were in total coordination and communication with Portugal, because they at the same time worked on their eradication program. And we were able to eradicate practically at the same time in 1995, both countries. But if a country that's close to you, you have no contact with them, at the end of the day, you're going to get the disease back. A good coordination is fundamental for the success of a control program, and if at all possible, eradication. And I'm going to end with 4 or 5 slides to send you a couple of messages. I am no longer in the lab contingency plan, which is much of the field of Carmina Gallardo. She coordinates our lab, but we'll work on the same program. It's fundamental to recognize the disease at the field. This is the first pillar, because veterinarians are the eyes that are going to see for the first time African swine fever. So they have to be there and recognize clinical presentations. And I would like to add from what Dr. Gallardo said, you must not think that the virus evolves from virulent virus to moderately virulent and then to attenuated virus. With time, virulent viruses yield to the appearance to moderately virulent viruses, which are the ones that infect from acute to subclinical or subacute, chronic or subclinical. But the thing is that the virulent virus continues circulating. You have the virulent one, the moderately virulent, and after 2 years, of course, you're going to have attenuated viruses there. We know that is the case. We have experienced that in Spain since the 60s to 1995. We have been in Africa, we have been in the European Union, and African swine fever is always African swine fever, no matter the genotype. Genotype is just a way of classifying or tracing molecularly. But genotype 2 has virulent viruses, moderately virulent and attenuated. Another genotype has exactly the same virulent, moderately violent, and attenuated. All the viruses we know have the same characteristics. In Africa, we do not talk much about this. But that is the way it is as well. We've been there, we have experienced that, and there are works that describe this. And we have analyzed this. Awareness and training of veterinarians at the field is essential. African swine fever, well, this slide that you see here, this is a world that, this slide I put in a presentation in 2015 or 16. It had just entered the European Union, but we knew that this is like a fire. If you don't stop it, it grows and grows and grows, and there's no way you can stop it later. So I'm going to give you some additional advice, but Carmina also gave you, and perhaps we're going to overlap with our advice there. But this is additional advice for early detection, because at the end, it will reach you. And I'm going to give you a couple of messages. Epidemiological scenarios. You have to look in veterinary services greater knowledge of epidemiological scenarios in the different regions. One country is not homogeneous. You have to have a risk analysis to prioritize introduction and expansion routes and have some passive surveillance, but surveillance at the end, which is for routes of introduction and possible expansion. Then you have to implement surveillance activities that are risk-based surveillance activities. Because the first thing that you need to do is to study the scenarios. And where am I doing more legal introduction? I'm having animals that are coming in illegally. Am I having them through the ports or airports? Because the exploitations that are near ports and airports, because they receive all the offal from the vessels and the offal from the airplanes. Do I have a lot of irregular migration? These people can bring snacks. For example, in Russia, there were interesting leaps. The disease appeared in one point and 1,000 kilometers away. It's because the mothers were sending frozen meat to their children in the military headquarters for them to cook their food. And that was a way of transmitting. And it's been proven that the meat was sent because there's a lot of virus in the freezers at homes. Raw meat has lots of viruses. An animal is slaughtered, frozen, and sent to a sun that's far away. That sun takes that meat, throws it to the backyard, and the offal is eaten by the animals there, and then they get sick. So that is important for the early detection. Awareness is very important. Important points that limit early detection are the low presence of veterinary services in an area, deficient clinical suspicion communication systems, deficient differential diagnosis at the field, as Carmina was saying, a bad connection or coordination between the field veterinary services and the lab. An inadequate lab capacity, a lack of supplies that does not allow me performing a quick diagnosis. The staff is not duly trained. And other messages to consider. In the European Union, in several occasions, I've heard that since it came from Eastern Europe, this very virulent virus came through there. Some experts of veterinary services said, well, since the animals died 6 or 8 days afterwards, well, if the dog is dead, the rabies is over. No, cadavers, mostly of wild animals at the backyards, are extremely dangerous because they maintain for long the virus in tissue. And in the forests, well, not to talk about that, that the cadavers are the real problem we have in the European Union. Wild animals, animals that are dying out in the field. And we have the circulation of virulent viruses with moderately virulent viruses and attenuated viruses. They're hard to isolate, but in our lab, we have been able to do that, and we found them and we classify them. And as Dr. Gallardo has said, there is a typical characteristic is that they are not chemoabsorbent, the attenuated ones, which are the hardest to discover. Survivor animals and recovered animals may play a role in expansion and maintenance of the disease, and they are easily detected by serological techniques. If vaccines have not been used, that's very important because current vaccines are vaccines that are being used in Vietnam or China. They do not say anything. They say that they have eradicated the disease practically, which is very hard looking at their map. But well, if no vaccine has been used, a seropositive animal is always going to be an animal that is in recovery. Reinfections play a role in maintenance because an animal that has survived the virus reaches again, they're going to have viremia because the virus is there are no neutralizing antibodies that virus replicates. But scientifically, we know that the animal that has had the virus and recovers will not get sick, but excretes the virus. So that's why, in the European Union, every seropositive animal needs to be slaughtered. And much of this that we're saying, you're going to find this in our web page. There's a web page that's very good, not because we did it, but we maintain it up to date. There is a lab drill. It's complex and you can work through it and solve it. And we also have videos of the pathology. We are now going to change to a new web page. We're going to be having more videos, and we're going to post those videos in Spanish because it's all in English right now. It speaks about the disease diagnosis of all the procedures, of all the SOPs, and but any working procedure for you to adapt it to your lab, you can easily adapt it easily from our webpage in English, or that's why you have put the mails when you can ask for it and we send it over because there's no problem. The web page is maintained by the European Union and that's why it's all in English, but we are going to include the whole lab simulation. This is not the typical one of looking at the techniques because look at the techniques and SOP and all that PCR. No, this is a simulation. You receive a sample and there you have it. It's called simulation. And right now, if you take this web and you write ASF reference lab, and immediately you get this first part, and then you get into simulation, and then you have an updated page where you have the whole epidemiological situation. And I hope I did not take too long. I usually take like 5 minutes longer or such, because it's very hard. We love to take advantage of the moment. This is the group of African swine fever where we work. not only give reference works, but also researchers, Dr. Jovita Fernandez, and we have Paloma Fernandez Pacheco, etc. And well, there we are for whatever you might need. Thank you very much.
Thank you very much, Dr. Arias. Both of you were able to elaborate on this topic in a perfect way, the need to convey everything that you have said so far. And we hope that the countries and those responsible for veterinary services and diagnostic laboratories were able to hear all this and get prepared and see what they're missing. What are the countries missing? What they need to implement. And you mentioned it wonderfully. It's not only a matter of knowing how to do the test and knowing the techniques, but no, we even asked them to invite the administrators because this is very important. Why are you asking me to buy these kits if the disease is not even in the country? Well, because it's very important. I needed to continue showing and demonstrating that there is no virus in the country. So yes, it is very important. And the only question that I was able to see here was if you had a template, but you already responded that. Yes, we have everything. Anything you may need, just send us an email. Send an email to Carmina or fao.asf and just write my name or their name. That way we can obtain the information. And we have templates for databases and for many other things. So send us an email. And many countries might also have that because they have that for other diseases. Yes, of course. And if you're not prepared yet because you have not suffered from these diseases or the laboratories are recently being updated or something like that, this is a time. And as you were saying, this is going to be good for you. This model is going to be good for you for other diseases too. So we thank you, Marisa, Dr. Marisa, for your presence, your presentation, and thank you so very much. We enjoy very much being with you. We are very close to the Americas. We love the Americas, and so that's why, yes, and definitely we feel that love, and that's why we invite you. And the fact that you are leading women, that is even more exciting. So now, thank you very much, Doctor. Erika, do you have anything else you would like to tell her? Well, and the Q&A session, we will see how much time we can have to answer the questions. Yes, I'm going to stay here, no problem. I'm going to stay with you. So amazing presentation. That's exactly what we needed to reflect, just like Dr. Camposano's presentation. So thank you very much. Thank you. Katia, would you like to say something? Well, I'm very happy because when we chose them, that was the idea for them to get to know to the region what they've been doing and for them to also convey the message that they are here to assist the countries, reference the laboratories and those who speak Spanish. We also have the option for reference laboratories that speak English as well, that are duly coordinated in a work network and that they have lots to offer countries to work on the diagnosis of the disease. So thank you very much, Dr. Marisa. Thank you, Katia. Thank you all. Okay, so now we're going to continue. We're running a bit late with regards to the agenda, but we're going to try to conclude 5 minutes before noon and with all questions and everything. So I'm going to ask, please, Dr. Eric and Dr. Robin to please help us with that. We are going to give you 20 minutes for your presentation, and we'll just give like 10 minutes for the Q&A. Now, we will look at the diagnostic experiences in the Dominican Republic. This is going to be presented by Dr. Eric Breton Guerrero. He is a graduate of the Utah State University in the U.S. with a degree in animal and dairy and animal degree. and he has introduction ISO 900 in 2015, client services, auditing, QS, and a regional course on laboratory diagnosis and of pathogenicity in 2023 in the University of San Carlos, Guatemala. From August 2021 to date, he's been working in the Central Veterinary Laboratory in the Dominican Republic as a molecular biology analyst in charge of molecular biology. And that's part of his CV. I'm going to stop here because it's also very long CV, but in order to save time, we're going to continue. So he will be talking about this topic as well. Well, thank you. My name is Eric Bereton. I work in ABC, as it was mentioned, in La Becen, as it was mentioned, but we're also going to have my team of molecular biology team, which is Jennifer Garcia and Emmanuel Martinez. They will be assisting me with the presentation. And yes, we can start. Can you see us okay? Yes, we see you. That's what I was going to say. If you can help us with the camera, maybe you can have the camera looking at the person who is presentation, and you can move the slides on your own. If you had any problem, we can support you. Okay, perfect. Thank you. Yes, I'm Dr. Emmanuel Martinez. Here we have Eric Breton, as he was introduced, and we also have Dr. Jennifer Garcia, who are all part of the team. We are a team of biotechnologists and veterinarians who work on molecular diagnostic and different diseases. We are working with ASF and the avian flu as well. And recently, we have developed tests to detect viral diseases in different types of fish. And the laboratory started working in 2021, which was when the where the first outbreak of ASF was detected. And so we are all working the entire sample for the country. We're the reference laboratory for the country. And we work hand in hand with USDA, with the Department of Agriculture of the US, and they assist us in confirming the diagnosis. They also do the genotypification of the virus. And so I was going to give you a brief introduction for African swine fever, but we have already talked about that. We know that it arrived here like in 2021. It is not known which was the specific port of entry, but there's different theories. Some people think it was because of the trash, but it was confirmed that the variety that we have here is the same as the one that we saw in Georgia. So we're working with the same strain. So it is a highly contagious, transmissible, lethal disease. It is spreads easily. And the second largest consumed meat in the Dominican Republic. So for us, it is an important impact for our agricultural economy. And so we have been developing a number of efforts to contain this disease. Even though we talk about different subvarieties or subspecies, can we skip this part because it was thoroughly explained and we can focus more on the current situation in the Dominican Republic? Thank you, doctor. And I apologize. This was prepared also for a more general public. So definitely, yes, this topic was already addressed during this webinar, so we'll move on. So we were going to talk about diagnosis and the clinical signs, but it basically presents the same as symptoms or signs as in other countries, but we have other noticed a few symptomatic cases with no clinical signs. And in active surveillance, we detect a positive eventually. And yes, with also with abortion in other areas. So we're going to move on we're going to pass the mic to Dr. Eric. Hello, my name is Eric. I'm in charge of the molecular biology in ABC in LabSN. I'm going to talk specifically on how we diagnose ASF here at LabSN. We mainly use the PCR technique, which you already know, and ELISA. So we use those two together because, as you was mentioned before, these are supplementary techniques that help us detect the virus in the early stages. And then the ELISA helps us detect when the viremia is moving on, is passing. And then here we can see the types of samples that we use. They have already been mentioned before, but very recently we also started using diluted blood in MTM, the molecular transfer method. And here we have a very large number of samples. So we use MTM to help us reduce the work burden because we have around 500 samples a day and we're only 3 people in the lab. So we use the blood pool at MTM. We have the clotting and 4 other tubes of MTM where we have the pool of the blood. They pinch the ear, take the blood sample and dilute it in the tube of MTM, and that's how we do it. Another type of sample that we have also worked, and it's not in the presentation here, but we understand they're going to start bringing us, is the saliva taken via a swab. Oh, they put a rope in their place where they live. They like chewing on the rope, so you can then squeeze the rope and get the oral saliva or fluid. And this is something that we're working with FAO. For us to do the PCR, we carry out the DNA purification through genetic material. There are 3 main methods. We have the column extraction, which is very poor, and the magnetic material we use, the magnetic beads, give high purity and genetic material. So the picture that you see there is one of our labs. You can see me there preparing the samples to put them in the Kingfisher, which is the one that does the extraction. I have personal protection gear, gloves. We work within a biosecurity booth, security level 2. And this is what we do here. This is an example of how the amplification looks like when we carry out a test. We don't not only work on ASF, but we also work on classic swine fever. And therefore, the yellow line that you see in the amplification line, that's the positive control for classic swine fever. And then you can see some of the red lines are some samples that were positive for ASF. And the blue lines are the control, positive control, internal positive control that we use to make sure there was no problem in the PCR in the pool there. So everything is validated individually. There was no problem with the PCR. Now we're going to talk about epidemiology and the current situation in the country. Jennifer will be talking to you about that. Hello, greetings. As we all know, we are highly contaminated and it's spreading in the backyards and organized farms. We also need to take into consideration that the movement of the virus must have a correct control of the materials and the use of the things in the farm. That's why everybody needs to disinfect adequately from within outwards or using correct disinfectants. In this case, sodium hypochlorite, which is the main disinfectant for this disease, for the equipment and for the areas. The current situation in 2022 and 2023, we can see the number of samples, 40,350 in 2022, and only 4% were positive. And in 2023, we processed 86,143 and only 0.67% were positive. And this is due to a very active surveillance system that is very effective. In the Dominican Republic, we have an active surveillance program, 100% all the time. Currently, during this first quarter of 2024, we processed 26,726 samples. Out of these, 148 were positive, and this then is a 0.55% of a positive rate. If a total of 27,770 animals were tested because the MTM was implemented. That's a tube that my colleague explained that allows you to put 5 animals in a single sample. And this allowed us to have more sampling in less time in more animals. And more animals obtained the outcomes. So, or the results. We had almost 1,000 additional samples done. In March, the last thing record, we had 7,955 samples with 48 positive samples. Here we have a map of how in 2022 to 2023, the disease moved throughout the country in 2020, between 2022 and 2023. We see how there were certain places that were negative, but now the entire country has shown both positive and negative animals. This animal shows the outbreaks between November 2022 and June 2023. As my colleagues had explained, these were done in the Central Veterinary Laboratory in the Dominican Republic in collaboration with the HEGA, DIRSA, and USDA. And something that we forgot to mention is that what we have has been donated by the USDA. Basically, everything that we use for the diagnosis of ASF was donated by USDA, and that's why the lab exists. We wouldn't be able to exist without them. We're very thankful to them. So this is our presentation. The presentation was very quick because we had it prepared originally for a more general audience. And all of a sudden, we were asked last night, you need to present tomorrow. So here we are. Well, thank you very much. We're going to continue now with Dr. Robin Joseph, and then we'll take the questions. Thank you very much, and to you and your team. We invite you to please join us till the end so we can do the Q&A session. And we ask all participants to send your questions via the chat box or the specific chat for the Q&A. Yes. Also, for those of you who are in social media, you can also send us your questions using the chat boxes of the social media. Yes, of course. Now, Dr. Robin Sandy Dorian Joseph, she has a master's in microbiology science by the New Zealand University. She got this on February 2023. This is a Master of Science in Microbiology, a postgraduate diploma in Science and Technology with merit in microbiology by the same university, the Massey University Tutia campus in New Zealand from May 2021. And in 2017, she obtained a Bachelor of Science in Biology with microbiology with an honors degree by the University of West Indies. Go ahead, Dr. Robin, you can move or pass your slides. And if you need our help, please let us know. She also has a very long CV. I'm going to highlight a few awards, achievements, and honors she has received. For example, in September 2023, she was part of the International Atomic Energy Agency Liquid Chromatography Mass Spectrometry Fellowship Program. She also was with Procinorte. She also had a project grant to understand the disease status of feral pigs and the role they can play in the dissemination of African swine fever in St. Lucia. August last year, she also took the African swine fever inspection training course. And on November 2021, she presented a poster at the 16th Congress of the Federation of Asian and Oceanian Biochemists and Molecular Biologists. She also obtained the support by a scholarship in New Zealand, the New Zealand Aid Scholarship recipient that finance her studies in that country. So it is a very long CV, and because of time constraints, we're going to stop here. But I just wanted you to have an idea of how good presenters are. And so I give you the floor, Dr. Joseph. Go ahead. Thank you. You are muted.
Sorry. Good afternoon, everyone. Thank you for having me here to give a talk on St. Lucia's diagnostic experiences. So as I mentioned, or as was mentioned, my name is Robin Joseph, and I'm not yet a doctor. Right. So this is just a quick synopsis of my talk. I'm going to have an introduction where I introduce our laboratory, the current disease status of St. Lucia, the Procinorte project initiative that has been launched, managing the diagnostic capabilities of St. Lucia, and our future plans to remain disease-free in St. Lucia. So the National Agricultural Diagnostic Facility opened its doors just about 4 years ago in 2020, and it was aimed at providing support for the providing diagnostic support for the livestock commodities in St. Lucia. Currently, St. Lucia is African swine fever virus free, and we would like to keep it that way. And because of this, we have embarked on various different initiatives to ensure that we remain that way. So one of the first ones is through conducting lots of testing, etc., but we are not quite at that stage as yet. So we are here we continue to do what we can as it relates to surveillance on the ports. And we also help, or we are embarking on giving the staff the training that is required in order to conduct those tests. Most of the meat in St. Lucia is actually imported, and because of this, it is quite important that we pay attention to our borders and to the meat that is being imported into St. Lucia. We also are quite, we want to function to create a sensitization project whereby farmers are actually, they are let, sorry. So the farmers, we're hoping to give them the opportunity to understand what African swine fever is and how it can be detrimental to the swine industry. So because of this, we need to make them aware of the signs to look out for in St. Lucia, and how they can reduce the dissemination of this disease if it happens to get into St. Lucia. But right now we are disease-free. So several steps have been implemented, like I mentioned. So the main one being port surveillance, the inspection of meat by trained officers. They actually know what to look out for when they are inspecting those meats. They also review the meat import permits to ensure that the meats are we gain the meat from countries which are African swine fever negative, because again, we don't want that tainted meat to get into the country where it could pose a problem. In St. Lucia, lots of the farmers actually feed their pigs swill, which is basically leftover meats and foods from normal households. So this is a way in which this can be disseminated if the imported meat is not properly cooked, etc. And like I said, we have the farmer sensitization activities that would also help with this entire initiative. So I spoke earlier, and it was introduced, the entire pro-seniority project, and basically we wanted to know how the feral pigs can pose a threat if the disease were to enter into St. Lucia. So we embarked on this initiative, which was also funded by ICA, where we sought to, or we are currently trying to elucidate how these feral pigs can have the potential, or whether they do have the potential to disseminate the disease throughout the island. The borders of St. Lucia are quite porous in that we are very close to the islands, both to our north, south, and to our east. So because of that, we need to ensure that we have a surveillance and passive surveillance being conducted in order to ensure that the country is rid or free of African swine fever. So the overall aim of this is to find out how these feral pigs can possibly disseminate the disease, but we're also hoping to test the capacity of staff. And by this, I mean that we were hoping that the staff can be competent enough to carry out these tests, such that if there were to be African swine fever were to get into St. Lucia, we are able to actually meet with those high throughput of samples. The project is currently carried out in different phases with the Forestry Department of the Ministry of Agriculture. And the first phase, which is where we're at the moment, is the location of those feral hoods. We currently don't know where the number of pigs that are currently in St. Lucia, the feral pigs. So our hope is to conduct some sort of enumeration study in order to locate those feral herds. Additionally, we plan to actually place some collars on some feral pigs so that we can actually monitor the migratory movements or the migration of these pigs throughout our forests. And this is important again because these feral pigs are actually in close proximity to the actual swine farms. So if, for example, there is African swine fever in that feral pig population, we want to see how, or the role that they can play in the dissemination of that disease. Secondly, we want to conduct sampling and testing. So if we do find any carcasses whilst we conduct our geolocation, etc., we plan to take some samples of whether it be carcasses or whether it be live pigs, so that we could either harvest the serum or the blood or the saliva, as mentioned by the other presenters, in order for us to test. Because yes, we're aware that we don't have African swine fever because the clinical signs have not presented, but we need to actually conduct those tests because this is important, and we need to continue to do those tests in order to ensure that we are on top of our surveillance activities, and to ensure that if this disease is brought into St. Lucia, we actually reduce the spread and we actually detect this disease very early. Another part of our personality project would involve the building of the capacity of the laboratory staff through lots of trainings. And we have detection methods in RT-PCR, so PCR as mentioned again by all the other presenters, as well as ELISA for if there is an immune response. So these two, not sure if you could see my mouse, but these two would actually work in tandem. So as we conduct the testing, as we conduct the collection, we actually conduct the trainings. So this helps build the staff and the competence in the methods. And then finally, once we have conducted all of these tests, what we hope to do is then to collate those results and then to actually confirm and report to WOHA that St. Lucia is, yes, indeed, free from African swine fever, and to also basically just give us a peace of mind knowing that, yes, we have done that surveillance and we continue to do that surveillance to ensure that we are free from African swine fever. So like I said, we are currently or hoping to utilize the real-time PCR for this analysis. And we have this piece of equipment here, which was donated, that we are hoping to use to do so. It is a qualitative method, but again, we have lots of commercial kits which have been donated to us that we can utilize for this purpose. So how are we managing the diagnostics in St. Lucia? Well, there are several things that we're hoping to actually do for the preparation of routine African swine fever surveillance. Firstly, we need to acquire the resources and consumables. As we know that laboratory reagents, etc., are quite expensive, and sometimes we may not get them in a quick turnover time. So because of this, it's quite difficult at the moment for us to, or it was quite difficult in the past to get those materials. However, because, for example, the constraints of the COVID-19 pandemic have sort of eased off, we are now able to get more resources in. So we're hoping, or we have started actually, to get those resources that are needed so that we can conduct this African swine fever surveillance. Again, like I mentioned, we have multiple staff training opportunities for detection methods, including PCR as well as ELISA tests. Then we need to actually perfect the technique of sample acquisition, because this is something that we've never had African swine fever, so we're not very used to the methods and certain, I guess, in this case, biosecurity measures that need to be undertaken. So this is another important technique, or this is another important activity that we need to sort of perfect, because if we indeed, or we do have an African swine fever outbreak in St. Lucia, there are certain biosecurity measures that we would need to follow. So we would like to have this technique perfected, or if not perfected, but at a very high standard, so that when we use these molecular transport media tubes, we would ensure that the samples are of good quality and we could expedite result acquisition. So in particular, we were looking at the molecular transport media because, again, this one helps with the preservation of the samples for long or for extended periods of time, of 7 days at ambient temperature and 28 days at 2 to 8 degrees Celsius. So this was something that we were actually looking at. What are our future plans for St. Lucia as it relates to African swine fever? Well, here at the NADAF, or the National Agricultural Diagnostic Facility, we're hoping to complete those trainings before end of year so that we can have the staff competent enough to conduct those high throughput sample analyses as well as reporting. Once we get this training and the lab tests running, we hope to then conduct an interlaboratory testing, routine interlaboratory testing, so that we can ensure that the detection methods that we use are actually sound, they comply with international standards, and that the staff are actually adhering to those standards. And this is something that we have not done and we hope to do in the near future, hopefully in the last quarter of this year. Then our future plans would involve the continuation of the passive surveillance along our ports as well as in our swine farms, because like I said, St. Lucia's borders are a bit porous. So we want to ensure that this is always conducted to have a quick detection, if any, of any African swine fever that might infiltrate our borders, as well as having a continuation of the passive surveillance of the feral pig populations. Again, we don't know how many pigs there are in the wild, but we know that it is a big problem for lots of farmers, swine farmers, as well as crop farmers. And if they're everywhere throughout the island, we would like to know how many, or a rough estimate of how many are there, and the migration or their movements, so that we can then plan ahead if we were to have perhaps an outbreak, let's say in the south of the island or in the north of the island. We could know which areas can sort of be sectioned off or be quarantined to avoid the dissemination. So those are our future plans, as well as to always seek help and seek some mentorship from our partners, especially through ICA, so that we can get that support to continue this work of keeping swine fever out of St. Lucia. I would like to thank you for listening to my talk. And I just wanted to say thank you to ICA for actually helping us and funding the ProSeniority project. We started off last year in around, I think last year, November or so, and they have been supporting us throughout this entire initiative. So we're hoping that we could complete this project by next year, March. Thank you so much for having me.
Muchísimas gracias, Robin, Joseph.
Thank you very much, Robin, Joseph. I have a problem, even though we do not have the degree of doctors here in Mexico. Once you get into the School of Veterinary Medicine or zootechnicians, we are called doctors, and everybody who is within this field are called doctors. So that's why I called you doctor.
Okay.
It's just a way of talking for us.
Yeah.
Thank you very much, Robin.
Thank you.
We are now quickly moving on to questions. I'm so glad that you mentioned the ProSeniority project. That is something very important that ICA is supporting. ICA Canada is currently the chair of this project. So that's something that we would really like more people to know about, and for all to know that we had the support for this, so that you can have complementary studies to what you already do in your countries with support of ICA. Thank you very much. We have a few questions. I do not know there's one specifically for you. Let's give the people time. I invite participants in the social networks and here in the Zoom. You could please write down your questions. We have a big crew behind the scenes that's providing us with support for that to catch all the questions. Let's begin with Dr. Marisa Arias. Marcos Faveiro from Senas, Argentina is asking, the run you showed with real time with results for classical swine fever, African swine fever, and internal genus control. Did you do that simultaneously, or how was this run? That is a question for those in the Dominican Republic, for Eric. Go ahead, Eric. Yes, good question. Yes, I'm going to show you the graph that it is talking about. Give me just a minute. Can you see it?
No, no se ve. No.
No, we cannot.
Bueno, en tanto les repito que por favor escriban el nombre de la persona a la que
Please
se
write
referirá
down
para
the
evitar estos
name of the
errores.
person who is asking and who the question is addressed to. Yes, this is the graph that you was talking about. The question was if the ASF, PCR, and all are done at the same time, and the answer is yes. We conduct multiple PCRs that detect the three targets through different channels, like the PPA, which is the main thing that we're looking for. We use the FAM channel, which is the standard that we use. We try to detect this using the peak channel, which is a bit less sensitive. I think that the difference when we do the PPC using FAM against peak, the difference is from 1 to 3, and the sci-fi is used for CY5 for the sin for the sign, and the sign is something that we verify during inspection inside the booth. I add the sign against the lysis, and the sign helps validating that there was no reduction in the PCR, or that there was no contaminant material that inhibits a PCR in the extraction step. If there is any material that's going to inhibit the PCR in the extraction, it would inhibit the sign, and we would not be detecting it in the amplification step either. Yes, I think that if we add 2 microliters of the concentration, this that we do to detect the PPA and PPC in all the materials, we were provided the materials that we use, and with that PCR method that we use also.
Perfecto,
I
gracias.
hope you answered.
¿Va a ampliar la respuesta?
Are you going to expand on
¿Va a
your
ampliar la
answer?
respuesta? Gracias, es que casi no se escuchaba. Bien, tenemos otra pregunta para usted, doctor. ¿Nos puede explicar con detalle el uso de la soga para la
Can you
obtención?
explain in detail the use of the rope for getting the saliva samples that you mentioned? Not so much in detail, but that's something that is being implemented on the field. It's not up to us. It's just that we've been told that we're going to be doing that. They're going to begin with those samples. But the idea is that in the corral where we have the pigs, we put a rope that's tied to the corral, which apparently is something that they like to chew on. I don't know, to play. They like to chew on that. That rope absorbs the saliva of the pigs, and it can be used as a type of sample that the corral in general. What we're going to have is a combination of saliva with all the pigs. We're going to consider that if we use that sampling the the saliva is diluted. So if we have this saliva is going to be very diluted. So we're going to be using it for several pigs. And something else to take into account is that it depends on the pigs. If the pigs, if one of the pig is sick, it's going to have less energy. It's not going to be wanting to the stronger pigs are the ones that are going to catch the rope. So that type of sample that we is that I'm not so sure how validated this is, but there are some things that we need to fine tune yet. I don't know if it's still great to use this method, considering the issues there might be.
Gracias, sí, sobre todo era por eso la pregunta en ese
Thank you
sentido de
very
ver
much.
si
That's
tiene
why
alguna
they were asking the
validez
question if it had been validated.
Tenemos oportunidad quizá
But
en otro
we'll
momento
have the
de
chance in another
ampliar esa
webinar
pregunta.
to hear more
Hay
about
alguna
this
más,
method.
Rodolfo, dice para que
There's another
no
question.
se
It doesn't
nos
say
olvide.
who it is
Dice,
addressed
¿qué
to, but it
protocolos
says,
utilizan
it
los
asks if you
veterinarios
have a
para tener
protocol to do the
observación de
test
servicios?
for ASF from waste or trash. Well, I don't know if the question is for us, but we do not use trash or waste. We don't get that type of samples. And so far, I think we don't have anything validated for that type of sample, just for blood, tissues, and I think it was validated for MTMs, for the blood, for MTMs. I think that part was validated too. We are accredited with ISO 2025. And so for us to accept a new type of sample, we need to do the validation on our own. And that's something we need to keep in mind. But we want to do that because we want to use MTM because it lightens the work burden.
Tenemos otra
Okay?
pregunta para
Yes, thank you.
Arias.
Another question for Dr. Arias.
Cristian Carvalho dos Santos.
From Cristian Carvalho dos Santos, what measures should laboratories adopt to make sure that the samples are being collected, storing, and sent in an adequate manner to the laboratory? What measures should be adopted? Well, everything needs to follow a protocol that ensures that the samples will arrive in the right conditions to the laboratory. So veterinary services and laboratories and veterinary services will send procedures to the vets for sample collection, how it should be done, and then to do the sending and the shipping. If it has to be sent to a reference laboratory, it needs to follow, there is a standard to do this type of shipping.
Muy bien, doctora.
With regards to waste and trash, just like with meat, to do a PCR, the PCR will detect the genome. So you never know if the virus is alive or dead. Let's suppose it's alive. But if you take a sample, maybe you take a sample in a piece of meat or in a piece of trash, you take a bit of trash, it's negative, but then there's another one that is positive. So it is very hard to be able to reach a conclusion from there. A positive will always be positive, but a negative, you never know, it may be positive. So we have to be very careful with those things. In terms of meat, the exudated of the piece of meat is well pressed and the meat is well pressed, and then that may work because you're taking that from the entire meat sample. But just taking a tiny piece of the meat sample is not good enough because you know if you're not taking that a part that doesn't show the virus, but the other part of the meat shows the virus. And in this case, doctor, it would be the same in the case of waste or the meat products that are retained at ports and borders. What would you recommend to do this type of surveillance or do something else? Well, we know that there is traffic of processed foods or almost processed, but we always think that we have had samples from customs from the EU because we work with the EU, and we have analyzed those pieces of meat and they have turned out to be positive and they may be sausages and it's processed and the pig was not showing that it was sick. We don't know if they had sent a huge sausage, maybe, but we don't know. So I don't think that's useful. I think it is much more important to do the traceability of the product, to know exactly where it's coming from, and knowing that it's coming from a country or region free from the disease. And as a preventive measure, it's good for it to be checked. I am guessing they make a selection or something, but it's very complicated. And then we have tested a couple of times and the animal was never sick. But then it's with this type of product, sausages, we don't know with others. Yes, thank you very much. That's very important because there are countries where resources are very minimal and it's best to use resources in a good manner, in a good way with all the protocols that you have shared with us. For example, the topic of looking for these feral pigs or the boars in St. Lucia is very important because there are certain countries who do not know if they have the population or where it is located. So that is very, very important. It is very important to think about the studies to determine if they exist and what the risk is. We have another question for Dr. Breton. Thank you very much for the answer. I'm guessing this was about the techniques they used. And what do you use to amplify, Dr. Breton? For the amplification, we use the kit of ACPAS. And that are also supplied for by USDA. And for extraction, we use magma score, which is by systems. That's the one we use. I'm gonna write it in the chat box. Yes, please. And we are also being asked if it's possible for you to share your contact information. If so, please write your email in the chat box. And we have one last question that is not necessarily related to ASF, because it is a question of whether cases of classic swine fever has been detected in South America. So there are two questions there. One says classic and another one says ASF. So for ASF, the only reports that we have at WOH, and we have a sub-regional representative from WOH here. We have Haiti and the Dominican Republic, no others. I don't know, doctor, if you'd like to add something else? No, that's all we have. In the meantime, we would like to invite countries to continue with their surveillance and do their due diligence so that each of the country representatives who participate in these activities develop their work plans and activities, and if they were requiring support on our end to get in touch with reference laboratories, we're always here at your service. And you can establish strategies for prevention. Of course, we all hope for it not to come into our countries, but at the time it does, it's best to prevent than to cure. So prevention is the ideal thing, but if it comes into your country, the idea is to adopt the necessary actions and measures to stop it early. So that would be everything on my end. Thank you. Thank you very much. Yes, Dr. Aris? I would like to add, there was a question about the vaccines. If they were using CRISPR technology. And yes, there are a number of groups, at least in Europe and also in the US, that are working on the development of vaccines. In China also, lots of groups are working on the classic vaccines do not work well. They don't work at all. But still, we're still looking into that pathway. We're trying to see what we can do. But the vaccines that are coming out are from living viruses that are removing the genes regarding virulence or virus replication that are virulent or attenuated. Our group is working in Europe using a highly attenuated virus where we are removing the virulence genes and marking it so that we can differentiate it between those animals that were vaccinated and those that are infected. We have made some programs. We are using CRISPR technology. We have 21 institutes intervening here, and there are 3 very strong European groups administering groups. So many countries are being involved from the EU, developing a vaccine against ASF. So hopefully very soon we will gonna have some diagnosis that will allow us to differentiate and hopefully we will get the vaccines. But developing a vaccine, you first have to develop lots of in vivo experience because we cannot use a rat, a laboratory rat, or a guinea pig. We need to use a pig. So many studies have to be used, so we move slowly, but we move forward. There are prototypes that do not produce disease. The virus using the vaccine does not produce disease, and at least 50 or 60% of the animals are protected against a virulent virus. And we even have others that reach all the way up to 90%, but those have not been studied thoroughly. And it's also being studied in limited number of animals. So all of this needs to be taken into a larger scale. And so people are happy because the vaccine is being developed, but we need a safe vaccine because it is a living vaccine. So safety is always on top of protection. So thank you very much. We're going to conclude here because it's noon and we get our transmission cut off. I would like to say something. I, when I talked about the kit that the ACPath is the one that we use for influenza. The one that we use for PPA is Pac-Man Fast Virus One-Step Master Mix. We use the Prime, the Probe, but that it was my bad. The ACPath is for avian flu, but the one that we use for ASF is Pac-Man. Well, thank you very much, Doctor. It was written in the chat box too. This presentations can also be seen online. We already put the web online, the link online. We would like to thank all the doctors, Dr. Arias, Dr. Murillo, Dr. The Director, Dr. Breton Guerrero, Dr. Clovin Joseph, Miss Robin Joseph, and all the people who participated here as panelists. And we ask you to please join us, continue joining us, and invite your bosses and those in the administrative area because all of this is very important. The doctor says, Dr. Ida says something very important. Communication. Communication is key. Communication is understanding what the other party is doing, coordinating. It is very important to prepare ourselves and prevent the disease to spread in the other areas or countries in the American continent and the Caribbean. So thank you all very much. We would like to greet you all. Have a great day. And goodbye. Thank you.